GRETL. So since you already have GRETL, and then I know that you would in the future you would be asked to do a little bit of forecasting, or days or months or years step ahead of forecasting, maybe your sales production, maybe your number of harvests yung aning mga prime commodities, energy needs, maybe forecasting the number of population growth, something like that, notwithstanding the effect of other factors or variables, then Arima could be a better tool for that. So, but before we delve on the um, basics of how Arima is estimated, especially in GRETL software, in which you already have, I would be discussing to you what these things would be, and how would it affect you, or how would you use them in the course of doing your development research administration, public administration, or urban and regional development, no, course would be. How would it help you in order to become better in the PhD program? So I would be giving you some hints on what time series is, ano yung mga properties ng time series data. Some of you have used time series, like a couple of you, like 2 or 3 of you are using time series data. Then approaches to time series analysis. So we already know what ordinary least squares is. Nagkabalo na taon saon pag estimate sa regression analysis, just using independent variables going to regress to dependent variable. But I think we were not able to cover regression using its constant as a regressor alone, or using itself as a predictor. So we will be discussing Arima or Box-Jenkins model, but we're not going to cover LSE or least squares estimation procedure and SIMS because we're running out of time. Medyo ang Arima kasi is very tricky. And then we will be discussing what stationarity and unit roots are and its implication in the actual forecasting. And some other things that you might want to explore in your own time using the GRETL software, like the error correction model or the co-integration test would be the Johansen-Johelius co-integration test, time varying parameter models, the vector autoregression, the VAR framework, and the ARCH or the volatility models like autoregressive conditional heteroskedasticity model. So of course, maybe you would be interested to learn it because last night may software na kayo, pero siguro the springboard of everything would be learning the autoregressive integrated moving average. So why is it called Arima? Why is it called time series? Because there's a specific time horizon or a specific time element in that particular data at a specific fixed or constant or consistent time definitions. Meaning to say, if this data is month A, you're expecting that the next data would be month B. And then the next data would be corresponding to month C and so on. Hindi pwede na month ito, tapos half of the month ka dito, tapos week ka dito, tapos month ka na naman, that represents specific data. So it has to be consistent for it to be forecastable and better, no, or it could be consistent when you do the estimation procedure. So there's this particular element of time that is being considered, since time alone is considered to be a predictor of your variation of your data. So for example, if in case we're talking here of population, ang population growth ng Pilipinas or ang paglobo ng population is a matter of time as well, because given in its own, population will grow over time. So yun yung mga specific scenario ng time series. So a time series is a collection of data y sub t, where t equals 1, 2 large T. That means that T there stands for a specific point of time, and a continuous growth, or the end point of that time horizon is labeled as large T. So wag nyong tag nito, If in case you would be representing time series, report the number of t as small t equals a specific number of time horizon. So let's say 60 months, then that means the time series is reported to have small t equals 60. Okay. If in case the small t is unknown, then you will denote it as large t because it has to be established yet. May range ba ang time for it to be used sa time series? That's a very good question. No? So, ang time series, wala naman talaga. By definition, it's not actually saying na you would have this minimum number of series or number of times for it to be considered to be a time series. The series as alone would not mean that it's only one time or two. Hindi man nato siya makonsider na time series kung two. Maybe a couple number of regularities of time, let's say 5 months or 5 days, that already indicates a specific series of numbers represented by time. So, meron din namang specific na mga time series analysis tools that are very particular on the number of observations or time horizons for you to actually use it in forecasting. So that means that even if there is a specific number of days or months or years, like 5 months or 5 years or 5 days, which is considered to be time series, it cannot actually mean that you can use it for forecasting purposes given the limited number of times that you have for the estimation procedure. So it could actually be a series, but it cannot actually be used for forecasting, something like that. So wala namang specific cardinal rule that this should be the minimum number for everything. So every time series models have it or has its own number of has its own assumption that includes the number of times or the number of time horizons that you're going to use. For ARIMA, they suggested it to be at least 25 to 30 time elements or time dimensions or your time points. Let's say you have at least 25 years, then at least it can give you something na pwede na ka mag-forecast. It can give you already an estimate. Pero if in case na short times lang siya, then there are specific models that would apply to it. So let's say five time points. May mga specific short-term forecasting that applies to it, and ARIMA would not be applicable for it. So the larger or longer the time, can you ask it by opening the microphone na lang? So the larger or longer the time, the higher. What do you mean by higher?
Ang gusto ko lang malaman doon kung mas mataas yung coverage ng time, like 10 years. Yung
What
forecasting mo ba mas
what do you
maganda
mean
yung
by
result?
higher result of forecasting? I'm not so sure how it's
Yung,
defined.
yung
Accuracy.
tama ba na yung
Okay.
correctness.
Correct. Okay, reliable. Si Joanne ang nagsabi na may reliable. So, would it mean ba na the
Ito.
higher the number of times that you have, the more reliable your forecasting is? Hindi. It doesn't follow that way because there are a lot of considerations apart from the number of times that you would be considering when you want to have a reliable forecasting. And since we're doing this we're doing time series forecasting which includes inference, that only means that your specific forecasting is covered by confidence level and margin of error. So of course, it's not really it's not you are still bounded by error, and there is still there is confidence level in the forecasting in there. So ang tanong na magiging reliable ba kung napakahaba ng time series mo? It really depends on the data. So for example, stock market data on a daily basis. So if in case na mag-forecast ka based on regularity, based on seasonality, marami kasi tayong i-explain pa later, no? So what if ang forecast nimo in 2019 that if in case you are asked to forecast in the next 6 months at the end of 2019 na maganda ang ekonomiya, mataas ang ekonomiya based on previous data based on napakahabang daily data since January 1, 2006. But then we didn't anticipate that pandemic came. No? On March 15, lockdowns immediately happened. So that is already something that we consider as a factor affecting your forecast. No? So it is considered to be an externality or an error. It could be a shock on the forecast or a shock on the time series. So hindi, kahit napakahaba ng time na ginamit mo for the forecasting, but then again, there are specific factors affecting the series, making it unpredictable or volatile or something disrupted by an externality, then your forecast before is not reliable. Now, meron ding magtatanong sa atin na pwede ba tayong mag-forecast? I have already a daily data, I have already a monthly data, something like this of this data. Can I do a 10-year monthly forecast? Ang dangerous yun kasi we don't know what would happen in the future. No? Prediction is merely prediction based on historical data. Now, ang safe natin na assumption is that the nearer the forecast on the last immediate values, the more reliable it is, or the more the least would be your risk, or the least would be the error. The farther the forecast to the last value, then that means that it could be more unreliable. Kasi pagpalagay natin na meron kang 10-year forecast based on 100 years mo na data, do you think conditions in the future will not change? No? So tama maybe ang forecast mo on year 1, on year 2, but year 3, year 4, year 5, if hindi natin alam kung ano, hindi natin alam na merong mga specific disruptions. So I should say that all models, including time series models, are subject to reliability issues, and you can actually make sure that your series would be reliable if in case your forecasts are near the final values. So yun lang. Now we can think of time series as being generated by a stochastic process or the data generating process. So like what we do in data science, we always ensure that the data that we are using for time series has the following elements, no? That has the specific elements that are needed for you to have a better estimation procedure. Dapat kompleto yung time mo, wala kang missing values. If in case may missing values ka, you're going to put a lot of effort in determining what the values are in that particular days. Or if in case there are specific allowable na assumptions na pwede kang mag-replace missing values with a specific something, you need to declare it so that yung forecast na gagawin mo is something that is really it is worthy to be utilized, or magagamit talaga siya. Kasi kung ang dami-dami ng issues ng dataset mo, then your forecasting would actually be prone to a lot of misinterpretations or errors. So, of course, part and parcel of the consideration would be determining whether the series can be forecasted in itself, or there are specific variables that are used for forecasting. So, a good example of that would be forecasting enrollment. So, ang dami-dami ng studies that enrollment forecast or the previous enrollments would determine the next enrollment. But then, again, because you are predicting and you are bounded by R square and adjusted R square, time in itself only explains a variance of the enrollment changes. There could be other factors that could explain the increase or decrease of that enrollment. And you might want to get data of those other factors so that you can regress them to your enrollment data. So which means na hindi na siya univariate, it's multivariate already because you are using specific variables that could actually explain the existence or the fluctuation of your enrollment through time. So since ang ating focus would be univariate time series, that only means that we would be using the data in itself as an independent variable so that you can predict itself, which is also a dependent variable. So nakikita nyo yung concept na gagamitin ko ang sarili ko so that I could explain myself in the future. So that's basically how forecasting is done in the univariate approach. So a time series is a particular realization of the data generating process. So we call the entire breadth or stretch of your data, the entirety of your time series as the DGP or the data generating process, or the population, kumbaga sa cross-sectional na mga surveys. So population, and then ang time series is just a sample of it. Let's say, ano pa ba? Population from the beginning of time. Siguro, ang Pilipinas, hindi ko alam kung may record ba tayo ng population talaga natin since 1521 when Magellan discovered the Philippines, something like that, or Roy Lopez de Villalobos was able to conquer the Philippines, or have really ceded it to Spain. Wala siguro tayong record noon. But if in case meron tayong record from the beginning of time up until now, then we call it as DGP. That means that's the entirety of the population, or that's the entirety of the data from the beginning of time talaga. Now, what we have in our records, what we have in the PSA, what we have in World Bank are only population from years 1930s, pre World War siguro, no? 19, let's say 1920s or 1930s up until today. So of course, wala tayong data before 1920s or 1800. So wala tayong data na ganoon. So ang data na meron tayo ngayon is only a sample that's only documented, no? It's only a sample of the actual entirety of your data to begin with. And we call it time series. Because a time series is merely a sample of the realization of the entirety of your data, which could be only documented at the time or the specific coverage of times that you have. And the data before it may not be actually real data, but merely ginatawag na merely estimation or estimates, and not document because they were not documented before. So kung ang population nato, ang census nag-start sa Philippines during the American period, that means from 1902 hanggang 1920s, then they could have estimated only the number of Filipinos at the time in the past 333 years. Kung mga Amerikan nag-unsa. When the system of census, wala lang. Okay. So when the system of census was established by the Americans in the Philippines, that's the only that time na nagkaroon na talaga ng official data. Nagka-disruption during the Japanese period. Walang klaro kung ilan yung namatay talaga during the American-Japanese War, something like that. Nag-World War I, nag-World War II. And then when the Philippines was emancipated from the Japanese in the 1940s or in the early 1950s, then that's the time that we have documented our own population growth up until today. Pero prior to that, wala tay data ana, and that supposedly is part of the entirety of the data set. So time series analysis is the estimation of difference equations containing stochastic or error terms. That's according to Enders in 2010. Meaning to say that the data in itself is prone to errors, prone to noises, prone to a lot of errors in estimation alone or with other predictors. So some example of time series includes a single time series. So an example of that is US presidential approval, like monthly, or stock market. Stock market ng Philippines, PSEI. So single time series yan. Or enrollment data ng USEP. And then number of militarized disputes in the world annually. So, militarized disputes alone is a single data. Or changes in the monthly Dow Jones stock market value, or yung value ng stock market ng US. And then we also have pooled time series. Itong pooled time series includes or has some examples here, like dyad year analysis of interstate conflict. So since interstate conflict man, it could be country 1 versus country 2 conflicts from this period to this period, country 1 versus country 3 for this same period, and country 2 and versus country 3 for this period. It could be state year analysis of welfare policies. So may year, tsaka meron kang states or countries. For example, um, ganing number of beneficiaries of pensions of all countries from 1920 to 2022. So napakaraming countries niyan. So of course, it's not a single country, or it's not one series alone. Napakaraming series 'yan. Or country year analysis of economic growth. Let's say GDP, quarterly GDP of all countries from 1941 to 2022. So of course, from Algeria and Alabama up until Zimbabwe, then meron kang specific data for it. Now, what are the properties of time series data? So that includes the following properties. The first property is that time series data have autoregressive or AR terms, moving average or MA terms, and seasonal dynamic processes. But the very basic ones, if in case your time series does not exhibit any seasonality, at least it should have um, either or both autoregressive and or moving average terms. That means that when you can use it for forecasting, it's either autoregressive or it is moving average. I would discuss. There could be a discussion of this each of this one by one here. Check wala. Later, I would define it in GRETL later. Now, because time series data are ordered in time, past values influence future values. When you do your prediction, you always use of the past data sets. Now, there's a question raised by Jim kanina na ano ba ang definition natin of a reliable time series? Dalawa ang ating ang konteksto niyan. So first context, the most immediate past values are the ones that explain the future scenario, or the ones that explain future values. That means that in order for you to forecast the future, you will have more emphasis or better appreciation on the immediate past values. Pagpalagay natin na population growth ng 2023 is to be forecasted this year. Ano ba ang number of Filipinos, ng population natin last year? So usually yan ang tinitingnan instead of looking back in the 1920 population where napakalayo na niya. Second context is that the most immediate forecast values are the ones that are more reliable compared to yung nasa dulo na. So of course, it's striking a balance between immediate past values and immediate future values. That's the most reliable areas of time series is in the context of prediction. Okay? So then again, time series data are ordered in time, which means that time 1, time 2, time 2, there is a specific order that has to be followed and has to be ensured. Okay? So you're not going to arrange the data according to the highest or the lowest, but you're going to arrange the data according to the order of time. Now, this often results in a violation of assumption of no serial correlation in the residuals of a standard OLS model. So when you go back to the ordinary least squares model, we are particular with assumptions of no serial correlation. That means your error term has to as much as possible be smaller. So when your error terms are large enough, then your prediction values would be put into question, because your system or your prediction is bounded by a lot of errors. It could be because there are specific factors that you were not able to account that could better explain the dynamics of your forecast. Baka in itself, pagpalagay natin, ang R-square ng prediction mo ng enrollment is only 5%. That means the predictions that you would be doing is only reliable because time explains 5% of it. The 95% others are factored in your error terms because you were not able to define it as a regressor of your current prediction. So kung time lang ang gamitin mo and you would say nga mamang ato ang enrollment next year is kuan from 432 masters sa USEP mabot og 1,000, tapos pangutanon dayon ka sa dean nga unsa di ay ang imong mga regressor. So di ang imuhang mga factor nga consider sa prediction. Time lang ma'am, in itself lang. Now what if na statistician sa inyong faculty mga tana pila di imong R square? O dito ka mabuto kay 5% ra imong R square. So we will not discount the value of the tools under forecasting as a basis of decision making. So if in case ang R square natin is malaki, that means that at least you were able to account majority of the variance of your prediction from the factors or data sets that you have. Pero kung 5% lang imong R square, medyo careful ta na sa conclusion. So for this one, anyone can give me an idea what the behavior of this monthly presidential approval data from 1978, first month to the 7th month of 2004 looks like? Any specific ones? Any specific observation? Kevin, gusto man imo ang mastorya ka nag-time series man ka o Google Trend?
Seasonal po, Doc.
Bakit siya seasonal?
Kasi may increasing and decreasing pattern po.
Okay, so pagpalagay na lang natin na ang isang taon is measurable, ang dalawang taon is, or at the point from 1980 to 1985, the center of that is 2.5 months, or 2.5 years. And then we're going to divide that into 4, let's say, sorry, from 80 to 85, 5 years yan. So let's say 1/5 of that is 1 year. Now, from this point up to this point, you can actually say, or you can actually see that the rating of the president is the highest in January and begins to decrease in the middle of the year and recovers just right, or just before the year ends. Okay, this one, makita nyo ang aking scroll, no? This one is January. This is the start of 1980. And this one looks to me as January of 1981. Because tumaas ito ng konti, nagbaba ng konti, tumaas saglit. So it could be exhibiting seasonality, or it could be exhibiting cyclicality, or both. Because there are possibilities that the patterns that you can see in 1 year, there could be a repeat of this would be possible in the next year and in the subsequent years. So it means that apart from being seasonal, that a specific period of time in a year is seen as a fluctuation, as a major disruption or fluctuation of the data, and it repeats in the next year or the next 2 years, 3 years, something like that. This means that this could occur again in the next time periods. So that means it could be cyclical. So, do you think you can do some forecasting ng ganito, Ma'am Orfa? Nandito ba si Ma'am Orfa? Ma'am, do you think we can reliably do some forecasting using this particular data set, Ma'am Orfa?
Yes.
Do you think reliable po yung magiging forecasting natin given this particular behavior of the data? Wala si Ma'am Orphan? Wala si Ma'am Orphan. Wait. Ay, since wala si Ma'am Orfa, siniko na lang. Do you think mas reliable atong mahimong forecast ani given this behavior of the dataset?
Doc, I think magamit siya to make it reliable kung magdugan tag intervening variables.
What do you mean by intervening?
Like, for example, Doc, kung mo-forecast nga within the 1990s, taas ang approval rating ni President sa US because this is the end of the Cold War, Doc. So perhaps natay mga certain i-include nga variables like unsay current world nga mga issues nga pwedeng mo increase sa mo dugang sa approval rating or mo decrease sa approval rating. Kana ang akong interpretation, Doc.
Sige, it could be an intervening, it could be an influencing variable, no? Pero kung kana man gud ang atong tan-awon, it could be another line of data set. No? So just the data set alone without any other factors that might influence into it. Do you think that the pattern of the data that we have here can be used for forecasting?
For this data set alone, Doc, I guess dili siya enough, Doc.
Dili siya enough? What do you mean by dili siya enough?
Dili siya reliable to forecast
Okay.
approval rating.
Yeah. So, bakit siya hindi reliable? Because hindi naman siya as in a hindi reliable in itself, but it could give you a questionable forecast, no, when you have this data set. That's why econometricians or those engaged in time series forecasting sometimes would need to stabilize the series first, because as you can see here, this looks to me that it looks erratic to me. Una siya og heartbeat ba nga murag kung sa heartbeat pa makita nato na siya ang iyang systole ug diastole, ang iyang heartbeats per minute. Kung tan-awon nimo murag naghihingalo man ni diri oy. Nagtaas kaayo siya na nahagsa siya, fallen out. Murag grabe ang iyang pagkahagsa in a short span of time from 1991 up until 1993. Kung tan-awon nimo diri napaka steep ng decline. And when your series exhibits rapid increase and decrease and rapid ganing plunging in a very short span of time, that means that your future forecast would have a specific error that is would exhibit a large error kasi hindi mo alam kung ang forecast value is near the high or near the low. So of course, kailangan mo munang i-make sure na ang series mo behaves on a specific regularity for you to actually provide or do some sort of forecasting that is near the highest and near the lowest. That's why when you do your forecasting, even if magpo-provide siya sa iyo ng isang date, isang value ng future forecast, it is always bounded by maximum value and minimum value. So makikita natin yan sa confidence intervals. So confidence intervals, that means it would give you an average forecast for the next period, but it could be higher than that but not higher to a specific value, or it could be lower than that or not lower than this value. So it could be ranges. You could be correct. You could be still correct if in case your forecast is above the value that you have derived, or you're still correct if in case the value is below that. Basta ranges ang imong i-report. That's why when you do your forecasting, hindi pwede or hindi sapat na isa lang na value ang i-derive mo. You have to report the forecasted value including the lower bound and the upper bound forecast. Because walang, di man tamadam auring na makabalo kung unsa ang exact na specific values. Because there are specific variables that could intervene in your forecast. Now, when you first learn about serial correlation in OLS or in regression, you probably learn about techniques like generalized least squares to correct the problem. Yung ating assumptions sa ordinary least squares or sa regression analysis na kailangan normalize ang imong normal distribution ng imong residuals, makita nimo sa imong QQ plot nga kuan nga kanang ang katong imuhang mga errors kay duol lang kayo sa line, ang imuha bang kuan ang imo bang histogram kay bell-shaped curve na siya. Mao na siya kasagaran ang mga strategies nato in determining whether your regression analysis has serial correlation or not. So kana ang permintigid nato kung DRA ta specifically or kung PhD ta, dili enough na mag-report lang tag beta coefficient. So R-square, adjusted R-square kung regression ha. Kinahanglan i-report nato ang tanang assumptions. Why would you need to do that in your dissertation? Kung magre-regression kayo, bakit nyo kailangan i-report ang mga serial correlation, ang katong ginatawag nato na R-square, adjusted R-square, ang katong mga QQ plot, histogram, nganong i-report man to nato? Because it would validate that what you are doing in the prediction or in the forecasting is actually correct. No, so okay, is actually correct, no? So dili pwede na muhatag lang ka diretso og regression table without doing any sort of data pre-processing. Because then again, if you would be doing your statistical analysis in the future, statistics is one, but ganing data kanang data cleaning and data integration is another. the art of cleaning your data and ensuring that your data is really reliable for prediction is another concern. So of course, you need to ensure that there is little to no chances of serial correlation in your model so that your prediction would be ideal. Now, if you have higher serial correlation values in your regression analysis, that's not ideal because that only means that we can improve our model by identifying, as Kevin has stated, as Nico has stated kanina, some variables that could intervene or predict or influence your time series in this case. So if in case you have high serial correlation, this is not ideal because we can improve our explanatory and forecasting abilities by modeling the dynamics in YT using X sub T and error terms or E sub T. So that means that in order for you to really make use, or in order for you to ensure that you get the most the reliable Y, then you need to check whether the X variables that you have are really important or matter in the prediction of your Y, and minimize your error terms in the same time or at the same time. So the naive OLS approach, the ordinary least squares or the usual regression that you have, the naive OLS approach can also produce spurious results. Ano nga ang ibig sabihin ng spurious correlation? Naalala nyo ba? Ano ang ibig sabihin ng spurious or spurious? According to Gujarati and Porter in 2005 or in Gujarati 1995. Anong ibig sabihin ng spurious? That means that the correlation may give you higher statistical values but they don't make sense. Katong example gud nato nga i-predict nimo ang number of times ni appear si Nicolas Cage from 1990 to 2022 sa movies. Highly correlated siya sa number of namatay sa earthquakes per year. I mean, when does it mean nga kung maglinog, the number of time that the more nga daghan mamatay sa linog every year around the world, the more pud mo appear si Nicolas Cage sa films? Or daghan ang makapasar og PhD compre per year, correlated siya sa number of times nga kanang nagpalupad og spaceship rockets ang United States. Do you think madaghan ang mupasar sa kompre kung magdagdag og number of launches sa space ang US? Murag, it may be correlated numerically or statistically, but in actuality, they are not correlated. So we call it spurious correlation. And sometimes you may be forecasting or predicting something by including specific variables that could not make sense after all. What if ang imuhang economic forecasting or ang imong GDP forecasting mag-appeal ka din mag-appeal ka dag number of times nga nag-visit si Marcos sa gawas? It may actually look correlated, but in actuality wala pala sila talagang correlation. Something like that. So yun ang mga specific things that you might need to consider not only for univariate time series forecasting but also in the actual multivariate ordinary least squares regression analysis or the multiple linear regression analysis that we have done in the past. You need to ensure that your related literature tells you of the possible inclusion of this factor in the prediction. Okay, so property number 2 of time series data. Time series data often have time-dependent moments. Again, time-dependent moments. When you have a data, kung mag-forecast ka og data in covering these periods year 1 to year 100, of course, dili lang buot pasabot nga raw data ang naay time variation or time-dependent moments. Pati ang imuhang properties sa time series ana, ang imong mean, ang imuhang kurtosis, ang imong skewness, pati ang normality ana is time-dependent. So the mean or variance of many time series increases over time. Okay? So usually kapag ang time series natin is increasing, magkita nato nga increasing ang iyang unsa, the variance of that, the mean or variance of that is computed by taking into consideration the latest values of the time series vis-a-vis its initial values in the graph. So of course, kung pa-increase na siya, mag-expect ka diri nga taas ang mean diri in comparison to the mean of specific values in the first part of your series. So this is a property of time series data called non-stationarity. So this one looks to you, it looks to be nga kung ikwaon nimo ang mean score ani nga specific point, ani nga specific point, and ani nga specific point, lagyo kaayo ang iyahang variance ug ang mean siguro ani. And in factoring them all together, when you factor the considerations all together, it looks to me that you have a non-stationary time series. When we say stationary, that means the mean and the variance are almost the same at any point of the series. In its raw form like this, it looks to me that your series is non-stationary. That means kung may kang stationary, maybe ang imuhang data nag-fluctuate lang diri dapita nga area, magbaba siya gamay pero dili kayo baba ang igamay, magtaas siya gamay, something like that. So naay evenness, kung makita nimo medyo even ang imuhang series ana. Looks to me that this particular series doesn't exhibit stationarity. Maybe because there are a lot of events that have resulted or that have made the presidential ratings high in this particular area and low in this particular area. So, as Granger and Newbold in 1974 demonstrated, if two independent non-stationarity series are regressed on each other, the chances for finding a spurious relationship are very high. So, if in case you would have a non-stationary time series and you would not do something about it, when you do some regression, it could give you an R-square value of 0.9 above. And if that happens, that means that your correlation or your regression has serial correlation and spurious nature. So kung ingani sa akong gina-mention sa inyo ha, maybe the mean and the variance of your data for this is smaller compared to this area and to this area. So looks to me that this is non-stationary. So this one, makita nimo na baba kay diri, sa kagamay, nag-maintain siya. Kung may ka og stationary class, kini nga specific area here, let's say we can only use this particular area. Looks to me as stationarity in itself. But if in case when ka og kini nga period imong gamiton, looks to me that it's non-stationary because of the specific increases and decreases that are very far from each other. Okay. So when we say non-stationarity, it looks to me like this. So even if unsa, even if kini siya, what if kini siya, unsa ganini siya, Dow Jones value. Kung stationary nimo siya class, pareha siya ani diri o nga ang imong data is nagkuan lang gyud in this particular area. This particular area is also questionable because there could be some specific economic events that lead to the very rapid increase and decrease of your stock market in the US in here. So if the variance of a series is not constant over time, in this particular series, constant ito kasi it's just gradually increasing, decreasing, something like that. But kung maabot na kadiri, it could be heteroskedastic in nature. So we can model this heteroskedastic time series not using ARIMA but with some other volatility models of time series like ARCH, GARCH, and eGARCH. ARCH is autoregressive conditional heteroskedasticity. GARCH is generalized autoregressive conditional heteroskedasticity, and eGARCH is expanded or extended generalized autoregressive conditional heteroskedasticity. So if in case ang imong model, ang imong time series is volatile in nature like stock market, volatile man gid in nature sa stock market, di gyud ka maggamit og arimaan. Kaya naman, because it's already the type of data that you have is already heteroskedastic or volatile in nature. And ARIMA is only giving you two terms, autoregressive and moving average. That requires a little bit of regularity and stability of your series. Stock market is highly volatile in nature because of a lot of political and economic events. That's why dili ta magamit og arima for it. Now, property number 3 is that the sequential nature of time series data allows for forecasting of future events. So kung years 1 to 100 ka, imong forecast gid ana 101, 102, 103, 104, 105. Ayaw pag so forecast og 500. So immediate data lang, immediate times lang usang imong gamiton because of the sequential nature of forecasting. And then property number 4, events in a time series can cause structural breaks in the data series. That means that there are specific points of your time nga makonsider nato nga kini nga period is structural break. While I am interested to teach you structural break, ano na ba? Sige, tudluan ta mo later og structural break. Ginamit namin itong structural break na analysis kanang multiple breakpoints test sa forecasting. Katong ako ang advice karon diri sa UM, nag-MBA siya. Gusto niya mahibaw-an class ba nga naabay mga events kato ganing nagsugod ang stock market gani from December 1, 2019 up until early March 2022 or April 2022 last year. Katong iyang data niya ba? Gusto niya mahibaw-an kung naabay mga petsa kung naabay specific na-specific ba nga trading time sa stock market nga affected siya sa COVID-19 pandemic headlines sa balita pa. So, pangitao na nimo using structural break nga. Nganong makonsider ni siya nga specific time nga break ni siya? Because aning panahon na di ay nag-declare ang government na pwede na magmoderna. Kini di ay pwede na dai mo gawas. So, naay mga specific events that could likely explain a break of the series. And we call it events. So events in a time series can cause structural breaks in the data series. We can estimate these changes with intervention analysis, transfer function models, regime switching, or Markov models, etc. But we're not going to dwell on that because medyo sunggo na gini siya gamay. So we have a time to also on sa spare. So arima lang usa ta time series data lang usa ta using read. Now, properties of time series data number 5, many time series are in an equilibrium relationship over time, what we call co-integration. So when you see co-integration, that means, butang nato ba na number of the budget of the US for military and war. Tapos, napo kay time series nga the number of casualties in war with the US. Of course, kung integrated gud na, kung mo-increase ang imong budget spending for war, mag-expect yung ka nga daghang war gibuhat, so daghan gid pug mamatay ana. So when your series exhibits the same increases or kanang fluctuations, mag-increase diri, mo decrease siya, something like that, that means that the two different time series data are co-integrated. So visually you can see that nga nidaghan ang katong unsa, nidaghan ang nidako ang budget spending here, that's the time po dadaghag namatay sa war, of course. No, so graphically or visually we can see that, but statistically is we can establish that using error correction models or the error correction model or the ECM, no? So we call it co-integration. ECM requires that your data is co-integrated in nature. Apart from being correlated, they have to be co-integrated. Co-integration only happens if time element is existing. So unsay co-integration? Kita ra tag example. Maghimo tag Excel. So okay pa ta dira.
Yes daw.
Yes.
Okay, year. Spending. Debts. So let's say natay 2 years. Natay 10 years. 6, 7, 8, 9, 10. Let's say na ang spending nato diri is in billions of dollars. 50, 55, 54, ni kalit og 100, 75, 75. Nilingkod si Trump ni 125. Ay, siningkod si W. Bush 125. Then si Obama nag 150. Pagkaabot kay Trump 25. Buta na lang to ingana na lang ang mga scenarios, no. And then ang deaths nato diri is, let's say in terms of millions, let's say 0.5 or 500,000, 0.75, tapos 1.25, then kalit siya og ni abot og 7, 6, 6.5, tapos ni 8, ni 12, ni 7, ni kuan siya ni 1, tapos dili nakita is ni 1, like that. So if in case we're going to plot it in a time series, just an illustration. Tanggalon lang nako ning color blue nga year. This obvious na siya. So we can see here, medyo di lang nato ma-appreciate siya, no? You can see here, kung tan-awon nimo siya, medyo kuan siya, no? Kana ganing aquara good siyang in kuanon sa nako siya. So una ko ni siya pag kuan. Kanang chart type, change chart type, line, column, statistical. Ay specific ani nga dili siya mabutang sa isa. Column, line man gid siya, line. Okay. Statistical. Hindi wait lang. Kini na lang ato ang kuanon. So makita ninyo diri nga pag-increase sa spending ni increase pud ang debts. Ikuha na lang nato, i-multiply na lang nako siya og additional 10 na lang. This one times 10. Ay, sorry. C. Kuha na lang siya in 100,000s na lang siya instead of millions. Na lang siya. Para comparable ang imong unit of analysis. So, makita ninyo nga ang pag-increase sa spending, which is orange here, nag-coincide pod sa pag-increase pod sa imong debts, no? Sir, intentional man gud na nimo pag-type ang data, but I mean, this is an example of how the integrated time series looks like. They may be different data sets, but they are in philosophy or in actuality correlated with one another, no? So of course, debts and spending in war are actually, related. The other one is a cause, the other one is the effect. But as you can see here, when you plot them in a specific time series, their movement may be not really co-integrated through time. Not really kanang sabay gid sila nga same gid nga ana nga gamay lang ang ilang hilang. Pero makita nimo na nine episodes here that the increases and the decreases are almost coinciding. So you can see here in 0.9 sabay siya nagbaba. Pag abot po diri sa 8, sabay siya nagtaas. Pag abot diri sa year 4, sabay siya nagtaas. So maybe this particular data set is co-integrated. But you can further test that using error correction models. Not just the graphical illustration into it, but at least you could hypothesize that the data could behave as a co-integrated time series. Now, property number 6, many time series data are endogenously related, which we can model with multi-equation time series approaches. So as sa atong ginaingon, ang time series data nga univariate kanang isa lang, dili enough na mag-forecasting ka always na kana lang gid imong gamiton. Ang time lang gid imong gamiton ng elements. Of course, you also need to include some other factors, confounding or predictor variables. So hindi na univariate forecasting ang gamitin mo, kundi multi-equation time series na siya. So napakarami niyan, pwede kang gumamit ng vector autoregression. maganda sana kung meron kayong special course in econometrics because we can actually include extension of these explanations, pero wala man ang econometrics sa inyong curriculum. So nevertheless, we can only focus in this particular univariate time series forecasting. Then property number 7, the effect of independent variables on a dependent variable can vary over time. We can estimate these dynamic effects with time-varying parameter models. So na yung mga specific time-varying modeling, like na specific times of the year, specific decades, nga ang imuhang regression is more sensitive or more ma-feel nimo, ma-estimate nimo yung effects in specific time period. So time-varying models na siya. So why not estimate time series with OLS? Yung mga ating mga dataset, bakit hindi regression against time katong rat model ba? Bakit hindi regression against time ang gamitin natin in the forecasting? Bakit kailangan pa tayo mag-auto-regressive integrated moving average? Bakit ARIMA ang kailangan natin gawin for longer time series? Let's say 25 data points above. Bakit nganong dili simple moving average atong gamiton kanang mga common gani nga ginagamit for short term forecasting? Because regression against time, for one, or OLS estimates are sensitive to outliers. You already know what outliers are, di ba? It could be a value that is very high or very low, away from the mean or away from the normal average of that, causing a large variance of your data set. So of course, sensitive kasi sa outliers, it violates the assumption of normality. So OLS attempts to minimize the sum of squares. Kasi when we try to predict something, you predict your y in an increase of your x, it's not a good, or it's not an applicable model for time series because sometimes we minimize it to sums of squares errors. Mo nang sa beta coefficient, ang increase nimo is upon an increase of an independent variable or upon an increase of time. It's not gonna happen in ARIMA because we are not just establishing here an increase of your x to increase or decrease your y. Sometimes, or most of the time in ARIMA, you're going to estimate whether it's autoregressive or moving average and whether your data is stationary to begin with. Of course, kailangan mong tingnan yan ng mga specific consideration, especially kapag time series. Because OLS, sir, unsa gunang OLS? Unsa gunang regression, sir? Remember mo atong makahimo taog unsa? Katuging makahimo taog equation ani niya kung gusto nato i-determine ang iyang unsa, iyang trend line, something like that. So after that, pwede ka mag-display equation on chart, display R-square on chart, something like it. So, kini siya is an OLS. This is OLS already with time as your independent variable, and your dependent variable is the spending. So as you can see here, kung titingnan mo, the equation is y equals to 2.0909x plus 64.4. And the R-square is just 2.71%. So kung OLS, ang iyahang kuan lang gid concern lang yun is an increase of your x also corresponds to an increase of your y. Linear kasi ito na relationship. So wala siya nag-factor in sa mismong property ng time series na is it stable, stationary, is it can it be forecasted using in itself, in itself regardless of the time that you have, the time horizon. Kung ingana manggod, OLS works if in case multivariate forecasting imong buhaton, but for univariate time series, sometimes models like regression against time, which is an OLS model, is not applicable. So of course, you would try the other one, which is the univariate forecasting. So OLS treats the regression relationship as deterministic, whereas time series have many stochastic trends. And we can do better modeling dynamics than treating them as a nuisance. Of course, when I say nuisance, basig noisy ang imuhang kiningani, ang imuhang series. Sometimes, lisod kay na siya kung mag-OLS ta because dili na niya kasagaran ginatagag consideration, hence dako kaayo ang imong variance or ang imuhang deviation. So, for us to really make use of it in reliable forecasting, kailangan sa nato i-stabilize ang series. So how do we do that? No, how do we estimate